In Chapter 12, we're in our third chapter of hypothesis testing. We've tested hypotheses for single variables in Chapter 10, and then two variables in Chapter 11. In Chapter 10, we did single means, single proportions, and single variance or standard deviation. Chapter 11, we did two means, either dependent or independent, and then two proportions. But what if we want to test more than that? What if we want to test a whole array of proportions? That's what Chapter 12 is going to be about. Chapter 12 is going to be if you want to test 4, 5, 6 different proportions all at once. You could do 2, but 2 is kind of lame. So that's what we're going to be covering. And there's two main tests that we're going to learn. There's the goodness of fit test and the test of independence. So section 12.1, we're going to look at the goodness of fit test. Now, goodness of fit test is a hypothesis test used to determine whether an observed frequency distribution from data follows a specific distribution from the null hypothesis. So, for example, you assume all the colors in an M&M bag are equal or something like that. Then you go buy a bag of M&Ms and you check it, something like that. All right, so your null hypothesis is always going to specify a proportion for each category. So you're going to say, the proportion for red, the proportion for blue, stuff like that. The alternative is going to say that some or all of the proportions are different from those that we expected in the null hypothesis. Keep in mind the degrees of freedom for a goodness of fit test is k minus 1, k being the number of categories you have. All right, so let's start off by setting up the null and alternative hypotheses here because this is a bit different than what we've seen before. So let's see how this works. We want to find the null and alternative hypotheses for the following and give the degrees of freedom. Okay, so the M&M company claims that in a bag of plain M&Ms, 13% are brown, 14% yellow, 13% red, 20% orange, 24% blue, and 16% green. But is that accurate? So the percentages the company claims are what we expect. But when we tear open the bag, we get what we observe, and then we would compare the two. So this is what we're saying we expect to have happen. So that would be our null hypothesis. And the alternative would be something is different from what they expected. Now the way to write that is what I have right here. So you write out each proportion. You say, okay, proportion of brown was 0.13, the proportion of yellow was 0.14, and so on. The alternative to that is that the distribution of colors differs from the above, or at least one of those proportions is different from what we have, or some of those proportions are not what we expected. There's a lot of ways to write the alternative, but it's interesting because you write it in words. You don't really write out any numbers. You're not assuming, I'm not saying, oh, the blue is 26%. That's not what I'm saying. I'm just saying it's different than what we said before. So that's how you write a null and an alternative hypothesis. You write all your proportions for the null, and then for the alternative, you write out in words that, hey, something could be different, right? So the distribution of colors, the proportions for each of the colors, that's another way you can say it, differs from what you have above in the null hypothesis. You could say differs from the null, assumed null values, or something like that. There's lots of ways to write this. Now, the degrees of freedom is your number of categories minus 1. So the categories here would be the number of colors. So there's brown, yellow, red, orange, blue, green. That's 6 colors. So your degrees of freedom would be 6 minus 1, which is 5. That would be your degrees of freedom. There, I got that to fit in there. All right, so you think a 6-sided die is fair and expect that each side should come up 1/6 of the time, but is it really? So you assume your die is fair, then you're going to roll it 1,000 times and observe the actual numbers that are rolled, and then you're going to compare the two. So I'm just setting you up for how this test would work, but the real idea about this is right here. You assume the die is fair, so you assume the proportion for each of the sides is 1/6 because it's a 6-sided die. So that would mean your null hypothesis is that they're all equal to a 6. And this one, since they're all the same, you can actually just set them equal to each other in a string. Say probability of side 1, proportion of side 1 is equal to proportion of side 2, proportion of side 3, and so on. Or probabilities, it doesn't really matter. And they should all be 1/6. The alternative to that is if this die is not fair, then at least one of those proportions differs from 1/6. Because the null would be that you assume they're all equal, and the alternative is that, hey, something is different. You don't know which one. Now the degrees of freedom again on this one is actually 5 because there's 6 categories here. Sorry about that. So degrees of freedom is 5, because there's 6 sides. 6 minus 1 is 5. All right, now what about this one? Republican voters have to vote for a candidate in the primary for U.S. presidency. So based on the polling, we expect that Rick Perry will get 32% of the vote, Mitt Romney will get 41%, Ron Paul will get 16%, and so on. But does that, what we observe on election day, match the distribution we expect? Okay, so the distribution you expect is this. The proportion for Rick Perry would be 0.32, the proportion for Mitt Romney is 0.41, and so on. And the alternative to that is that at least one of them is different from the other. But of course, if one of them becomes different, then the others all become different as well. Like if Ron Paul all of a sudden gets 30% of the vote, that's going to affect what's up for everybody else. So the way we write that, well, there's a lot of ways to write it. You can say the distribution of proportions differs from the above. You can say the distribution of the voting proportions is different than what you expect. It's different from the null, from the null values. Something like that. There's lots of ways to write this. All right. And the degrees of freedom in this one is not 5, so let's figure it out. There were 4 different candidate ideas there, right? 4 different categories. So 4 take away 1 would be 3. So that's your degrees of freedom on this one. Rick Perry, Mitt Romney, Ron Paul, and other makes 4 categories. 4 take away 1 is 3. All right, I'm going to stop right there with this one. I know I could go on, but I'm not going to. I just want to let this video be about making your hypotheses. Let's make a note at the bottom real quickly. The alternative hypothesis can usually be written several ways. Is written in words, and there are several options. The idea is that you just want to make it so that you're saying that the distribution of those proportions is not what you expected from the null. And there's a lot of different ways to write that, but in general, that's what you're kind of shooting for, that what we said was the distribution is not correct. In that null hypothesis, you assume a certain distribution, right? Like this one. So you assume this distribution, and the alternative is that that distribution is not correct. Something is different, right? You don't know which one might be different, but something is different. All right, I'll see you back here to talk about observed and expected frequencies.